So now what we're doing is we're taking our systems and we're using applications. Okay? We're going to be having to write some equations and then use our systems to solve said equations. It's going to be super fun. The absolute first thing you want to do is identify your variables. Your variables are going to be the things you don't know. Generally, they're the things we're solving for. What the question wants us to find is going to be our variables. Okay? It's our unknowns. Usually use X and Y. You can use whatever letters you want. I don't care. X and Y is the absolute first thing you need to do is define your variables. Tell me what they mean. So I'm going to start with X and I'm going to start with Y. Okay? The Hilton University Drama Club sold 311 tickets for a play. Student tickets cost 50 cents each. Non-student tickets cost $1.50 each. If total receipts were $385.50, how many of each ticket were sold? What does the question want us to find? The number that was sold. Okay, so those are going to be our variables. So X will represent student tickets sold, and Y will represent non-student tickets sold. Okay, define your variable. Always start by defining your variables. Because in a lot of these questions, there's going to be two blanks. Okay? You can write an equation, great. But if you don't define the variables, a lot of these questions have two blanks. And if you get two numbers, and you don't know which one's which, you're going to get frustrated. Because if you mix them up, then it's going to say it's wrong. Where did I mess up? Put the numbers in the wrong spot. How do I know where they go? You define your variables. Define the variables so when you get X equals this, Y equals this, you know what that means. Define the variables. So we define our variables. We've got X and Y, student tickets and non-student tickets. Okay? So now we're talking about two things with our tickets. We're talking about how many we sold and how much money we made. Okay? We're talking about tickets sold and money earned. Tickets sold and money earned. Okay? So we're dealing with two different equations here. That's why we have to use these systems to solve, because I'm talking about two different things. Alright? And I'm solving for two variables, and I don't know what both of those variables are, so it means I'm going to have to use a system. Alright? Tickets sold. If I have a certain number of student tickets sold and I have a certain number of non-student tickets sold, how would I find that total amount? I would add it up. I say, hey, I have X number of student tickets, I have Y number of non-student tickets. I want to add those together to get my total. So if I take student tickets sold and I add it to the non-student tickets sold, I'll get my total. Okay, so I'm writing it out in words so you understand what is this concept that we're doing. I'm taking how many student tickets I sold, I'm taking how many non-student tickets I sold, I added them together, that's going to get me total. And then I'm going to look back in the question, I'm going to see what represents each of those things. Well, what represents our student tickets? X. I'm just looking at tickets sold. X represents our student tickets sold. What represents our non-student tickets sold? Y. What represents the total number sold? 311. So there's my first equation. X plus Y equals 311. So now money earned. So I need to look at, okay, money from students, and I've got money from non-students, and I've got total earnings. Total money. I would add those together. I would add the money from the students and the money from the non-students to get my total money. All right. But now I need to figure out, well, how do I find the student money? How do I figure out how much money I made from students? Okay, 50 cents is what we're charging each student. Well, I don't know how much do I have from non-students. By what? What represents the amount of tickets? X. 50 cents times the number of student tickets sold gives me the money from all the students. I don't know how many that is yet, but that's my expression. So what about money for non-students? $1.50 times what? Did I sell 311 non-student tickets? Times Y. That's total. I don't know how many non-student tickets. Now, when I take all the money that I got from students and all the money that I got from non-students and I add them together, what do I get? $3.85 and 50 cents. $3.85 and 50 cents. So now I've got my two equations. Now I can solve my system using whatever method you feel like. You can use substitution or you can use elimination. Or elimination, your choice. Can I clear this? I need more room. Okay. So I have x plus y equals 311. I've got 0.5x plus 1.5y equals 385.50. What method do you want to use? I heard substitution first. What am I going to do with substitution?
Subtract x on both sides with the equation x number. And you get y equals negative x.
Now, if you want to use substitution, if you want to use elimination instead, if your first thought was, I want to use elimination, do it. Do elimination right now while I do substitution. See if you get the same answer. I mean, you should. You're going to get the same answer as long as you do all the math. Okay? Use whatever method you're most comfortable with. Doesn't specify how, so you get to pick. You type some math where you get a choice.
Is there one that would be easier?
Honestly, with this one, either one's going to be about the same amount of work. Okay? Substitution might be a little bit easier. Maybe. Maybe not. Okay? What am I going to do with this negative x plus 311?
You're going to substitute it for the y. 1.5x plus 1.5 parentheses negative x plus 311 equals 385.50.
So we distribute 4, 5. Okay. Combine like terms. What's 0.5x minus 1.5x?
1x.
Close. Less close.
Negative 1x.
Negative 1x. So negative x plus 466.5 equals 385.50. I don't know why I keep insisting on writing that last 0, but whatever. It's there. Now what?
Subtract 466.5
Minus 466.5. Negative x equals negative 81. So what does x equal?
81.
Now, a couple things. One, word problems. Get a collective groan usually when I mention word problems. But what I need you to understand is word problems are great. Word problems are really, really helpful because they give you context for your answer. Context is good because it gives you an extra way to check to make sure, does my answer make sense? Common mistake. A lot of you guys, and I heard it second period. I'm going to hear it again in ninth period. I asked 0.5 minus 1.5 and I got 1 instead of the negative 1. Which would mean that you don't have this negative on the x, which means you would end up with x equals negative 81. It's a common mistake. Negative mistakes happen all the time. So if you got an answer of x equals negative 81, does that answer make sense? I can't sell a negative number of tickets. It's not like issuing refunds. So that right there should be a sign that I can't get a negative number of tickets. Let me go back. Maybe I messed something up. I probably messed up a negative somewhere. Let me find that negative. Let me see what mistake I made. Does my answer make sense? A positive 81. Yeah, that makes sense. Okay, that's reasonable. Out of 311 tickets, 81 of them were students. Cool, that makes sense. Now if I got an answer of like 2, does that make sense? It's probably not. It's probably really not. I doubt only 2 students came to a club. All right. If I got an answer of 500, does that make sense? No, because that's more than the number of tickets I even sold. Okay? So, does my answer make sense? 81 is reasonable. What does 81 represent? Don't forget that. That variable represents something. It is a real thing. Student tickets. All right? Am I done? Now what?
Do you have to plug it back in, or can you just subtract it?
You're still plugging it back in. You get to pick which equation you want to do. You plug it back in here, yeah, you're going to be subtracting. So if I do 81 plus y equals 311,
And then when we put this in,
if it asked for an ordered pair, yes. If it said what ordered pair represents the solution, you would put it in. But usually with word problems, it's going to be blanks. And it's going to say, how many student tickets? 81. How many non-student tickets? 230. So it would specify and say, student, non-student. So this is kind of one of those rare times where you're not going to write the ordered pair because of the context. And we're trying to figure out what the solution is. Okay, we're trying to answer a question. And the question is 81 student tickets, 230 non-student tickets. If it was just those two equations in isolation, I said, what's the solution? Absolutely, we would write it in ordered pair. One number is 4 more than twice the second number. Their total is 25. Find the numbers. Define my variables, x and y. What am I trying to find? The numbers. So what could x be? I don't know which one specifically is greater than the other, so let's not be that specific. Let's just say the first number. And the second number. Okay? One number is 4 more than twice the second number, and their total is 25. Find the number. So I've got one number and a second number. Okay? First number, second number. So one number, my first number is x, my second number is y. So I have one number is. What does is mean mathematically? X is. X is 4 more than plus 4, okay? 4 more than something else, plus 4, okay? 4 more than whatever that is over there, okay? It's 4 more than it, okay? So I'm going to add 4. Twice the second number, well, 2y. So x equals 2y plus 4. Their total is 25. How do I find the total of two numbers? Add them up. Oopsies. what method looks like it might be the easiest to do?
Substitution.
Substitution. Why substitution? Why is it very simple? I want to clarify that. It's very confusing. The x is already by itself, so use substitution. It's already set up for it. Plug that in for x. 2y plus 4 plus y equals 25. Combine like terms, what do I get? 3y plus 4 equals 25. Now what? 3y equals 21. What does y equal? 7. What does 7 represent? The second number. How do I find the first number? Plug it back into the equation. Which one do we want to plug it into? Second one or the first one? Do whichever one you want. I don't care. X plus 7 equals 25. X equals 18. So what's my first number? 18. And the second number is 7. Plug it into either equation. It's going to work. At least it should. How this collective grown. Treacherous. Oh. They're really going to hate this. It's actually not that bad. They give us a formula which gives it out. Terry Watkins can row about 10.6 kilometers in 1 hour going upstream and 6.8 kilometers, going downstream, and then 6.8 going upstream in 1 hour. Find how fast he can row in still water and find the speed of the current. So, define your variables. What is x going to represent? How fast he can row. Okay, so let's call that Terry's speed. Terry's speed. Okay, that's how fast he can row in still water. What is y going to represent? Current speed. The currents. Not the current speed, the current's speed. Okay? The current's speed. Alright? Now, we're going to use our formula distance equals rate times time. And we're going to have two things when we talk about upstream and downstream. Okay, we're comparing his upstream and his downstream. So let's start with downstream. Downstream. Okay? What was his distance downstream?
6 point.
Downstream.
10.6.
10.6 kilometers. Okay? 10.6 kilometers. Now his rate. Rate is how fast he's going. Okay? So we have to use our variables. Okay? How fast he's going. Terry's speed and the current speed. So we're going to start with Terry's speed, because that's what he's doing, right? Terry's sitting there, he's rowing, he's paddling, he's sweating. Is the current helping him go faster or slowing him down?
He's going downstream, he's going faster.
He's going downstream, he's going faster. And you can compare the speeds. He went 10.6 kilometers going upstream, going downstream, and he only went 6.8. I can read numbers. 6.8 going upstream. So he went further going downstream, which means he had to be going faster, right? So if I have Terry's speed and the current is helping him, what does that do to his speed? It increases it. What operation increases? Plus. So the speed is going to be Terry's speed plus the current speed. Okay? Terry's speed plus the current speed gives that combined rate. And then how long was he paddling for? An hour. If I multiply by 1, is that going to change anything? No, so I'm not even going to bother writing it. Okay? Well, I'll write it. But then it'll go away. Okay? It's the rate times 1. But that times 1 is not going to change it. So now let's talk about upstream. What was his distance upstream? Okay? And then, again, we got Terry's speed. Is the river helping him or slowing him down? So what operation is that? Subtraction. We subtract the river speed. So based on how this is set up, and again, I don't need this times 1, so I'm just going to get rid of it. What solution method should we do with this one? Why? Opposite coefficients. Y already has opposite coefficients. I have a plus y and a minus y. Those are already going to cancel out. So let's go ahead and use elimination. Sets it up already to be a lot easier. 17.4 equals 2x. So what does x equal? Okay. What does x represent? What does 8.7 represent? Terry's speed. Okay. So Terry's speed is 8.7 kilometers per hour.
So all we did was find the average.
No. It's not going to be average if they have the same speed, but it's not exactly the average because we have 2 different weights.
Yeah.
So now we got to find the current speed. How do we do that?
Plug it back in.
Plug it back in. At least the answer to my questions usually end up being the same thing over and over. Okay. 10.6 equals 8.7 plus y. What was that, 1.9? So the current speed, 1.9 kilometers per hour. I'm going to do the setup for the next 2. I don't know if we'll be able to finish both of them based on our time. Yeah. Which part? Which color? Adding them. X plus x is 2x.
Oh, alright.
Candy Barrel Shop mixes candy worth $2 per pound with trail mix worth $1.50 per pound. Find how many pounds of each you should use to make 50 pounds of a party mix worth $1.80 per pound. Define our variables. What's x? Okay, so which one's going to be x? I have candy and I have trail mix. Pounds of candy. Okay, so pounds of candy. So what's y going to be? Pounds of trail mix. Pounds of trail mix. Alright? So she's mixing up a bunch of candy. And they have different costs per pound. So I'm comparing 2 things. I'm comparing weight and cost. So if I'm comparing weight, the weight of the candy and the weight of the trail mix, what do I do when I mix them all together? What operation if I have a bunch of candy and I have a bunch of trail mix and I mix them all together? Addition. Okay, so I'm going to add candy and trail mix. Add my candy, add my trail mix. What is that going to give me? What's the total weight? 50. Boom. There's my weight equation. Take my candy, take the trail mix, add them together, gives me 50 pounds for the total mixture. Okay. Cost. How do I find the cost of the candy?
So would it be 150 or actually 150
Yeah. So I'm going to add them together for the total cost. but I'm not just going to do 2 and 150. I'm going to do $2 for every pound of candy. And I'm going to do $1.50 for every pound of trail mix. Add those together. And that should give me $1.80 for how many pounds? 50 pounds. So $1.80 for 50 pounds total. The total cost is $1.80 times 50. And then I've got the rest of my equation. So I can simplify that as 2x plus 1.5y equals 90. Now I've got my system. X plus y equals 50. 2x plus 1.5y equals 90. And then we would go ahead and solve. I don't want to spend all the time going through that solution. You could solve using substitution. You could solve using elimination. Whatever feels most comfortable to you. X, which represents our candy, ends up being 30. So 30 pounds of candy. And Y ends up being 20 pounds of trail mix. So dot, 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 dot. Solve. So I'm going to give enough time to do the last question. Okay, solve using substitution, elimination, whatever method you want, but there's our solution. Can you wait 7 minutes? Maybe even 5. Yeah. Can you wait? I don't want you to miss a lot. Alright. The measure of the largest angle of a triangle is 90 degrees more than the measure of the smallest angle. The measure of the remaining angle is 30 more than the measure of the smallest angle. Find the measure of each angle. What's the measure of the angles in a triangle?
90. No.
180. Well, how do I find the measure of all the angles? Add them together. So 3 angles in a triangle added together has to equal 180 degrees. Okay, so I have angle A, I have angle B, and I have angle C. So I have to define my variables. A, B, and C. Largest angle, middle angle, smallest angle. Okay? So the measure of the largest angle is 90 degrees more than the smallest. So what expression could I use to represent 90 degrees more than the smallest? C plus 90. C plus 90. The measure of the remaining angle is 30 more than the smallest. C plus 30. Okay, C plus 30. 30 more than the smallest. And the smallest is just the smallest. Alright? So we're going to use substitution because I've got 3 different variables and I've got this formula so we can just plug everything in. What can I replace A with in my equation? Not just 90. C plus 90 because A is the smallest plus 90. Okay? What can I replace B with? C plus 30. Plus C. I don't need to replace it with anything. It is what it is. Okay? Do I have any distributive property? No. So I can just drop those parentheses now. Okay? So C plus 90 plus C plus 30 plus C. Combine your like terms. 120 plus 3C equals 180. 3C equals 60. C equals 20. Okay? 20 degrees represents what? Smallest angle. Smallest angle is 20 degrees. How do I find the middle angle? Okay, so what's the smallest angle? Plus 30. Okay?